You wait 3 days for a 3D sequence to render. You pull it into your timeline, and the objects still look artificially pasted into the background. So you tweak the lights, hit render again, and listen to the server fans scream while your electricity bills climb. We are going to stop that cycle right now. Instead of repeatedly kicking shots back to the 3D software for expensive re-renders, you will learn to build your atmospheres entirely in post-production. To do this, we are going to combine 4 concepts: depth compositing, analytics diagnostics, the Scrum VFX methodology, and Sustainabl VFX practices. By the end of this workflow, you will have complete control over your scene's environment. This animated diagram demonstrates the core tool we need, a Z-depth press. Think of Z-depth as a 3D radar map. It removes all the lighting, color, and texture, and instead generates a simple grayscale image that tells After Effects exactly how many units away every single pixel is from your camera. Shifting your rendering logic out of the 3D engine and into post-production saves days of waiting. It also drastically reduces the physical power consumption required to finish a shot. Let's apply a Scrum daily stand-up mindset to our workflow. Our immediate sprint goal today is simple. We fix the current shot right here in Compositing. We do not send it back to the 3D department. Step 1. Import your EXR sequence. Before you do anything else, go to your project settings and change your color depth to 32 bits per channel, or 32 BPC. A standard 8 BPC project only gives you 256 shades of gray. That is not enough mathematical capacity to store the exact real-world distance measurements spanning miles of a 3D environment. 32 BPC gives you floating point precision, ensuring your depth data remains perfectly accurate. With the environment set, we need to apply analytics diagnostics. This is the habit of analyzing your data mathematically when a composite crashes or generates ugly, jagged edges, rather than just guessing what went wrong. If you've ever had a depth composite fail, it usually comes down to one rule that goes against everything else you know about rendering. A Z-depth pass strictly requires aliased or jagged edges. It must never be anti-aliased. Look at this diagram. An aliased edge is the sharp knife on the left. It slices through the image, keeping the data pure and separated. Anti-aliasing is the dull knife on the right. It tries to make edges look smooth to the human eye, but mathematically it mashes distinct layers together into a blended smudge. If a foreground pixel is 10 feet away and the background pixel is 100 feet away, anti-aliasing attempts to blend them into a pixel that claims to be 55 feet away. That mathematical confusion is exactly what causes the dark fringing and edge halos that ruin amateur composites. Proactively diagnosing root causes like anti-aliasing errors keeps your data pure. It stops cascading mathematical failures from breaking the rest of your tools down the line. Now we extract the data. Apply the extractor effect to your Z-depth sequence. Your composition will immediately turn pitch black. This is expected. Go to the Extractor Channel Info settings. Assign the Y channel, the luminance channel, to red, green, and blue. This isolates the hidden distance data. Your screen will likely turn pure white. To fix this, locate the black point value in the effect controls. Dial it up in increments, often around 5,000, until you manually remap that invisible floating point math back into a visible grayscale spectrum. The visual language of this gradient is absolute. Tear black pixels represent the objects physically closest to your camera. Pure white pixels represent the maximum distance in the scene. Create a new adjustment layer and apply a depth of field or fog 3D effect. In the effect settings, select your newly extracted Z-depth sequence to serve as the exact source of truth for the scene's distance. This split-screen image reveals the result. The flat render on the left gains immediate atmospheric perspective on the right. Notice how the effect swallows distant objects in thick fog, while the foreground remains perfectly clear, based entirely on the Z-axis math. Because the fog is calculated in After Effects, you can change its density, color, and falloff in seconds. You have limitless iteration power, completely free from the punishing time constraints of a 3D render engine. We have the visual fidelity. Now we need to align this speed with Sustainabl VFX practices. We do this through integrated VFX scalability. Instead of pushing your local machine or a cloud farm to output a heavy 8K sequence, you render your initial 3D passes at a mere 2K resolution. We then bridge the resolution gap using green AI. By running the 2K render through an AI upscaling tool, like After Effects Detail Preserving Upscale, you restore the image to full 8K clarity. Think of it like planting a small tree and applying a highly advanced fertilizer to grow it instantly. It requires a fraction of the raw resources compared to forcing the earth to produce a massive tree entirely from scratch. This chart shows exactly what that means for your hardware. Combining a 2K render with an AI upscale reduces a typical 10-hour processing time to just 2 hours. That directly cuts the carbon footprint of your shot by 75%. Operating an eco-friendly workflow lowers your overhead. Consuming less electricity and finishing shots faster makes sustainability a direct driver of studio profitability. Look at this final render playback. The cinematic depth of field and the interactive fog rolling through the environment were achieved entirely in post-production. In our sprint retrospective, we can see that the success of this shot relied on diagnostics. By recognizing that anti-aliasing was the root cause of our edge errors, we kept our mathematical data pristine. Applying depth compositing gave us complete control over the atmosphere and eliminated the need to abuse the render farm. We achieved maximum scale with minimal resources. Integrate these diagnostics into your next project sprint. When you stop wasting time on brute force rendering and start manipulating the raw data, you build a faster, more profitable, and truly sustainable workflow.